very dangerous, gentlemen. And if you're on the wrong side of the politics of truth, that you could be crushed. And that is what I just saw happen in our presidential elections. It's not the first time. It won't be the last. And I'm telling you, secret societies exist for a reason. The keepers of truth go underground and hide for good reason. There are tunnel systems all over this planet for good reason.
Well, I mean, we've asked a question, me and some of my friends recently, okay? Check this out. This is how simple it gets. When's the last time your elected officials, like your congressman or your state representative, ever knocked on your door and sat down and said, Michael McDuffie, what do you think about things? What's your opinion on things? They don't do that. They just want your vote, and they may knock on your door, or they have somebody in their campaign doing it. But that's done away with. I mean, Representative Jack Murtha, who was
dissent is our only voice.
He did it, but you know why he did it too? Because he was vested in the community, because that's where he was from. He had businesses there. He had businesses all over our town. He was going to walk the neighborhood, and it wasn't for votes. He would walk the neighborhood and be like, "Hey, there's Jack Murtha." He would come sit on your porch, sit down and eat some food with you, visit people, and ask questions about, what's going on with you guys. What's your immediate needs right now in your community? That doesn't happen anymore. And he died shortly after Obama got elected. But that's just an example. It doesn't happen anymore, man. That don't happen anymore. People are arguing about this and that and the other and the third. And it's like, when have you ever come to my house, knocked on my door and said, Sean Andrews, what's your opinion? What do you think? They don't.
Yeah, I am not represented. My country does not represent me. We knew about how to deal with pandemics 20 years ago. We've known, and we've had lengthy and detailed plans in place to deal effectively with pandemics in place in our federal government for years and years and years and years. These ideas and these concepts are well known, and they were well employed in other places on the planet. We don't deal well with pandemics in the same way we don't deal well with the truth, because it's inconvenient and costly.
Well,
and we don't value life, we value money. And until our values are adjusted, I feel that the truth isn't necessarily going to save us, because it is not being rewarded. And those who speak against us are being supported and rewarded by powers that are greater than us.
The show is started, by the way, folks.
Cool. Welcome.
I'd like to point out that Neil has pictures of comets on the screen at the moment, and we're talking about politics. So maybe we should switch to electric universe stuff. And
I didn't want to interrupt the flow. You guys were having such a great time.
I saw you throw your hands up, Neil.
Oh, good.
Yeah, why not?
You know how I get sometimes, Neil. Every once in a while.
Oh, I'm not complaining. I understand.
Every once in a while, I get a bug in my bonnet, and
you're allowed, Duff. You're allowed.
There's
I'm a self-righteous bitch. I'll tell you that. I do have a high horse. So
this is relevant to the comets, because people are looking at comets and they're saying, what is it? The thing about his followers is that there's no difference between a paper tiger on the wall and a real tiger for people. They react exactly the same. It's kind of like WWW.
That's a very important point.
Yeah,
I agree.
And is that people will begin to believe something's real just that's being shown to them. And there's people in the world that know this, and science is not ignorant of this either. They use their organization in the same ways. They get the fans, followers, and it doesn't matter to them what the truth is. It's a matter of how much political power, how much stuff that you can get behind you that can't stop you, and you can get your own way. All organizations are susceptible to this. Even Christian churches are susceptible to this. And it's a daily struggle. Huh?
No.
I'm sorry.
Even by hatred. A couple of Tibetan Buddhists are susceptible to this.
Oh, God, yes. I mean, you can see them beating each other up in the streets when they're preaching peace little orange robes going and flailing with sticks. Yeah, it's a great time.
So Comet Atlas blowed up real good. Isn't that exciting?
Yes, it popped.
And then 3 days later, our magnetosphere, our shield, took a hit from the north that disrupted the shield big time. Isn't that exciting?
Hey, Rich.
Wow, I'm interested.
It is exciting. I got 4 words for you, buddy. Blue star, Kachina prophecy.
No,
I just hijacked your science.
It was green. It was green, by the way, not blue.
Blue star, Kachina prophecy, man. All right, you got to deal with it, though.
Blue sky.
Talk about that.
Smiling at me.
Oh, now I'm thinking of Data again. Oh.
Star Trek is on our brains.
Did you see that that Axonar trailer? That looks really good. I like that.
Oh yeah, bro. Oh yeah. I'm hooked into Axonar. I watch the live streams. He does 2, one in the morning, one at night, and then Axonar Comics. He does live streams as well, and he does comic stuff. It's great stuff, man.
It's nice that even you know what's interesting. One thing I like about Axonar is the idea that they too are going against the established canon. Well, actually, to preserve it, which is very odd. And it's just kind of the same feeling. I feel a kinship there, where you're like, no, we don't trust your science anymore. We're going over here and doing this kind of science because, you know.
Well, nobody did pre-Kirk until NX Enterprise, in other words, the show, and that is between Enterprise and Kirk, so that's a story that needed to be told, I think.
Well, actually, I'm trying not to judge that. Only because, obviously, with the introduction of the Borg in that particular timeline, you're going to have a third timeline that spins off. This is the one that, of course, is causing the problems with Discovery. But anyway, let's not dwell too much, since I think
Borg
about
and
this
Axonar, what?
See?
Okay, all right. Now you're getting into styles. I am a huge fan of the Borg, so that I have a question about. Do you think, in any frame of imagining, that it could be possible that there are multiple sort of variations of us that exist in multiple dimensions, and that someone in some dimension has just figured out a way to dump all the bad stuff on us?
Well, yeah.
We're
the micro of the macro, and the macro is us standing there, and we're inside it. We're inside its brain. So yeah, no.
I think the other dimensions figured out a way to dump their shit on us. This is what I think.
Honestly, I think that
we're the trash pile somewhere inside of the Milky Way.
Right.
And is Comet part of that, or what?
I don't want that shitty life. Give that to this other reality.
Well, I think that might be perception, because all I'm seeing is beauty constantly everywhere. So I think this is heaven, honestly.
Well, you just got a trip to the fucking beautiful mountains too, where you breathe fresh air and talked about how famous you're not. So.
Not allowed to talk about it.
Oh, sorry.
Still, I think that the problem with this type of honestly, when I just see what's happening with institutions and the way that they tend to have an inertia, getting over that is no easy feat. And you're right; they're all there to consolidate power. I mean, it is the way it is. I honestly do not know what to do about that on the grand scheme. The only thing we can do is be honest, try not to let people get scared. I mean, that's very interesting what you saw there, Rick, when you're mentioning, because if there was if the comet did pop or break up, it would be a circuit that it might have completed with our magnetosphere as it went down. Something like that could have happened. It's hard to guess.
It was. I think it was too far away from our magnetosphere to make contact with it. I think it punched through a double layer of the sun's magnetic field, and that area that it went into was
would there be
more positively charged. And then it blew up, and then the electric pulse. I think it was an electric pulse, not a magnetic pulse, that hit our magnetosphere from the north.
They're pretty much the same thing.
Disruption.
But yeah.
So was it vaporized?
What?
I mean, this was a huge object, right?
No, it broke. It just broke up. No, it's not. It wasn't.
Yeah, one day ago.
No. See that is the misconception. The nucleus of the comet is probably no bigger than Mount Everest, but its coma stretched across for, I think it was 720,000 kilometers or miles. That's 5 times the size of Jupiter. That's what everybody was misconceiving as this thing it's a freaking planet.
Well, that right there is what. Yes, obviously the people don't understand what the hell they're talking about, but that the coma of that body touching the coma of our Earth, that would be facilitating a connection.
Yeah, but we're not anywhere close to it. We're on the other side of we're starting to approach it now, and I think it's 2 months from now, we're going to be closest to it as it comes back around.
Well,
or the pieces come back around.
Yeah, I was going to say it's not.
Well, this is my question: is how many pieces
we're too far away from it for what I'm saying is our magnetic field is too far away from this thing for any influence other than an electrical pulse coming from that area down to us.
No. No, that doesn't exactly work that way.
Are the pieces going to hit us?
No. The pieces aren't going to hit us.
No, it didn't break up like a shotgun.
But what I meant is that even if the two bodies, the two comas don't touch, okay, they could. We've talked about this before, where the middle between the two objects, there could be a positive object form out of nothing, which is between the two objects. That could be the influence. I'm not trying to be. I'm just trying to say they don't just pop, unless because there's no big difference in voltage.
Well, we know space is plasma, so that would be able to carry that electromagnetic pulse or that electric pulse.
Yeah, but why? I don't understand why there needs to be a pulse in this equation.
Well, what happened when the comet blew up? It had to have given off something, no?
Well,
and it happened 3 days after it blew up.
It had to transfer charge from point A to point B. That's all it has to do. It doesn't have to be pulse.
Okay, so you're saying the hit on our magnetic field has nothing to do with the breakup of the comet?
No, I'm saying that it definitely have a relationship. They can actually happen further away than we might think, simply because of the likes principle that I was just describing. That's all I was referring to. I mean, the voltage between the Earth's orbit, where it generally is, and the sun was only 600 volts. I mean, there's not much voltage here change.
Well, if there's an instant connection, shouldn't that have happened instantly the moment the comet blew up? But it took 3 days to get here. That's my point.
Well, what I'm trying to tell you is that if you have a body and then you have, let's say, 2 negative bodies, and then in the middle a positive body will form. In this particular case, if you have a magnetic field around 2 bodies, then in between, even though they're not touching, a plasmoid can form between them, since one is incredibly huge. I'm not saying it did. I'd have to examine things a lot, more than this.
But we didn't see any plasmoids or any kind of
you don't have to see
visual connections.
Okay. You wouldn't have to see it at all. We're
dark mode. Okay, dark mode. Dark
it just
mode.
Basically has to. It just has to, because the Earth has a ton of charge on it, right? And if it can make a connection, that it would go, hey, you have a lot of electrons. Can I have them, please? That's all it has to say. There's no, and if there's a mechanism for it to transfer that, albeit a likes transfer. It's quite possible. I'm not saying it did, but these are the things I like to explore, because basically it's like space is filled with different, downward slopes and different potentials, and sometimes like a big two troughs can occur, and then a big positive trough can occur between the two, and then attract them, and of course it doesn't want to move, but it wants to take the electrons, since the comet can't really move that well, but it can transfer the electrons, and it blasted it to pieces. Doesn't, I mean, this, if it got close to the Earth, the same thing would have happened. I mean, it's discharging out there already that we can see it. We were going to see it with the naked eye. I'm kind of sad that we won't now. I was looking forward to that.
But when it popped, I'm looking at its orbit right now. When it popped, it was far, far, far above the asteroid belt. Maybe even Jupiter. So I think Jupiter's magnetic field would have affected it long before ours would have. If that's the case.
Let's take a look
I'm
here.
trying to find out where Jupiter was in its orbit. Okay, Jupiter, if you're looking at the sun and the comets coming in from behind us and above us, Jupiter was off to our right.
Actually,
so
I can see it on this particular graph right here, and it shows the days where it was. And of course,
March 13th, it's above the Earth, and Mars is off to the right of us, between Jupiter and Earth. So March 13th, it didn't blow up, right? It blew up before that.
the 11th.
It blew up April 9th.
Oh, I was still. Take a look here.
Well, I texted all that information earlier.
No, I'm just looking at the graph as it comes in.
I think a lot of people would like to know, or I'm sure that it's not clear to them, how exactly an object in space it is have, is not in equilibrium with itself, how it does in fact ground.
It does,
because that seems to me like that's the main thing, is that basically it's not equal with its environment, and therefore it's going to, as they say, pop.
That's
April
actually
6th.
correct. We don't have any connection. Like what happens is that every body that we have, being charged body, will basically insulate itself around the plasma that makes up the body that it's immersed in. We're immersed in the solar wind or the heliosphere, so we're immersed in the bubble the sun makes. And our planet has a tail on it because the sun has such a strong magnetic or a strong field that it pushes our field away, the one on the Earth. Otherwise, it would be Otherwise, it would be round, just like the sun's, well, more or less is. But each of these bubbles that they're in is sort of pressing up against other bubbles, which are other stars and other, and they have their own balancing act that they're trying to make with the magnetic field of the galactic arm, and of course all the tendrils and the local chimney and all that stuff. But when it comes to us, a little bit more local, we're basically, everybody is trying to ground ourselves, and of course when something becomes the most charged body, it attracts more charge to it. So it has more flow. And of course, that's exactly why the sun immerses our bodies. Eventually, when, like, for example, if there was an encounter where Saturn came into the solar system, there would be initial contact. Well, actually, there'd be, like we talked about before, just there, a contact before the contact, then there would be a contact. And then it would immediately want to try to give as much charge as it can to the sun. The sun would be going, I'm much bigger than you. I'm taking your charge. You're now going to get your power from me, basically, because you're now in a different equilibrium state. Well, that's basically what they do is plasma insulates itself around these environments. The Earth itself has its own insulating sheath around it. And so the sun, whatever voltage it is, it goes all the way to a certain point, and then from the sun's corona to us is about 600 volts. And then it goes all the way down to zero from about 500,000 volts to zero when it gets to the surface of the Earth. That's what we know. Now, we don't know the voltage of the sun, but it's estimated to be on the other side of a couple billion volts. So that's basically how we're sort of immersed together. And each one of these is like a where instead of water flowing, charged particles will want to flow down these gradients. And some of them, some of them are very weak and almost a capacitance layer because they barely move. And I use this in relationship to the Earth. But when it comes to the sun, the double layer is very active because basically the boundary layer has two potentials on it, and one attracts charges and throws them down that slope and off into space, and the other one pulls them in towards the sun. And that balancing act is equal. Of course, protons have more mass, but let's not dwell.
By the way, the comet broke up on April 6th, and our magnetosphere took a hit on the 9th. So 3 days later.
It would surprise me that it's somehow related, but I'd have to look closer to understand it more.
Esoteric Gold had a question. And I heard this too. I don't know where, and I just tried to look it up. I couldn't find it. But Africa recently had most likely a meteor hit, 75 feet by 35 feet, supposedly a crater, a few days ago. Has anyone else heard anything more about that?
Skywatch Media.
Is that where that information came from?
Yeah, he presented that.
Okay. Well, there you go.
At first, the government said it was an explosive truck, and then now some of the scientists there are saying it came in at a 43-degree angle and impacted.
So not a very high charged body, just traveling fast. Okay. Nothing too scary then. Nothing like a comet.
Yeah, I say that impacts can happen.
Of course they can happen.
But most of them are destroyed by a thunderbolt coming from the ground, like you suppose. I agree with.
Say that they. Well, I mean, if they're that powerful, yeah. I mean, that's what it would end up being. But most bodies don't come from the ground. They would have a. There would be a charge underneath of it. Because it would be coming in, like in 2013, that Russian meteor. I mean, there could be a charge build up on the ground, and you would have stories of
Tunguska. Yeah.
Well, that's even more powerful. But the one that happened in 2013 was weaker, way weaker than Tunguska, but also weaker than 1978 in Bell Island, Newfoundland. That was the big one that happened there. And if you were to examine, go door to door in Russia, which they never did, a lot of the windows were blown out and stuff. But just before, a lot of weird things would be happening, like blue flames would come out of electrical appliances, stuff like that, because the ground around the comet, or the rock as it was coming in 2013, would be attracting charge to the ground below it, even though it's miles away. And that would raise it above, say, 120 volts. So that suddenly you're running positive voltage as a ground through all of your electrical systems. And it would only happen for a little bit before the explosion happened, probably because it was coming down, from space, as it was wont to do. So in Bell Island, Newfoundland, it was investigated by the CIA. That's how much everyone went over that, because it blew out all of the electrical grid for the entire island, and one lady only lived like a few, like not even a year after the event. She was so shocked. Those screw-in fuses that you put into walls were found embedded in the far wall. They had twisted themselves out and shot across the room. So yeah, that's something that would happen if it was to, you know, round out. And that's just a minor event, really. But still, charge has to be dissipated. It can't, and it has to go downhill. It has to equalize. And the only way it doesn't is that there's a balance, like we have with the, you know, the Earth has a charge, and 500,000 volts later you're in space, and then 600 volts after that you're towards the sun. You know, but there's a boundary layer, and it sort of pushes up against this, attracts, you know, and sort of has this protective layer. And to get through that, you have one of two things. You have to be basically the same, you know, the same voltage as the Earth, more or less, or you could bleed out your charge as you come in, like the space shuttle does, or whatever. If not, you're going to zap and explode. And just like in 2013, that one didn't quite touch the ground, but the Earth's, all the ions in the atmosphere were attracted to this object, and it was like, okay. And it was like, okay, and as it kept going further and further in, the corona, or sort of the coma around it, was pulling in tighter and tighter and tighter. And as you study capacitance, you realize that even though the voltage is the same, let's say 500,000 volts, but that's at 50 kilometers. When you bring it further and further in, and gets tighter and tighter, then that spring is tighter and tighter. So the amount of energy it's storing is basically, it's holding that energy there on the surface, because a capacitor is an energy storage device, just like a battery. So this capacitor is around this rock, and eventually it touches one of the tops of that rock, and the coma and all the electrons that are around that ground out through that rock and blow it to smithereens into a shotgun of little tiny debris, which is what happened with the Comet Atlas there. It blew into 3 pieces, I think, probably on a lot of little tiny pieces. But exact same mechanism.
2 major pieces, and it looks like there's a cloud of debris behind it of smaller pieces. So, yeah.
Makes perfect sense. Which is really awesome when you think about it. I mean, the fact that this is, again, perfectly rational. I mean, you're bringing an object, and it could be because it was hitting the solar wind, you know, because if you're further up at an angle like that body is, the magnetic field will tend to drift towards the pole. So the current will be towards the pole. Or it could be that it was crossing the arm that was feeding the Earth, because we know that there's an arm reaching out of the Earth, and the north and south poles, and attaching to the north and south poles of the sun. So perhaps it went through that. You know, I honestly do not know. But wouldn't surprise me.
You know, I don't know how scientific this is, but I was going through the internet, and it showed this car-sized rock, and they said it fell to the ground. I thought, and it looked like it, you know, hadn't been pulverized in any sense in any way. Like, how could this huge-sized rock get down here? But if what was it coming down on was, you know, the Earth was shooting up on it as an equal amount of force as it was coming down, maybe it could land on the Earth. Now, I don't know if that's true or not. But the question is that how is it that the different layers are, you know, when does it decide to be equal or is trying to be equal with its environment, and when does it not decide that it can't do that, and therefore it's going to break these things up or whatever.
What you're talking about is it's actually referred to as breakdown voltage. I'll actually look it up for you. It's actually a really understandable concept. Basically, every object has the ability, just like there's resistance to heat, there's resistance to charge moving through it. So an insulator, like the air, has to shoot lightning bolts through it, you must overcome the voltage trying to hold it there. So it's basically saying, okay, there's 500,000 volts. Now we know that it breaks down quite a bit. We have sprites and then thunderstorms and all that kind of thing. So that breaks down. But the thing is that the air immediately fills back in that gap that was just made once the voltage decreases, and that barrier is resumed. So it's basically breaking down, failing, and sealing itself. It's called a leaky capacitor, basically. So when you have a break, we use these type of things in like Zener diodes and stuff like that. You don't have to worry about the names of that, but basically electrical breakdown is usually a bad thing because things, like blowing apart and, people on fire and stuff like that in the electrical world. But when it comes to like even a diode can only work so much in reverse before it eventually breaks down and fails. And some things can be designed to fail but then heal, so we use that technique a lot. But it's not really too complex. It's more like when it decides to go, it basically has to do with the potential that's coming in and the capacitance that could be held. And obviously, air at a certain point can't hold it anymore. In the transformers and around the power grid, we usually use like oil. We completely immerse it in oil. Or we use other mechanisms of ceramics and stuff to keep them from breaking down. More or less. Hope that answered your question.
Oh yeah, I was just wondering whether or not that could actually physically happen, that a large car-sized body could literally fall down and not break up, and
yes.
Okay.
Remember, if a body has to bleed off charge, then that's another thing it has to bleed off. Like if it's relatively equal to the Earth, let's say part of Antarctica, or a volcano threw it into space or something, okay? And then eventually it fell back down to Earth. Or it's, well, at that point, or maybe it was part of Mars, but it's been orbiting Earth for so long that it's now approximately the same voltage as the Earth. And then it falls down to the Earth. And no big deal. The Earth just has to absorb the heat of it falling, which is gravity and mass, and then of course the inertia hit, and it has to deal with that. But it doesn't have to deal with all the extra coulombs that the thing has and how it gets rid of them. There is none of those things in Comet Atlas. Comet Atlas was in space. It didn't hit anything. It had to basically, it crossed something that it said, hey, I have a lot of electrical potential asking for some electrons. I'm going to give them to that. Okay, and it did. And in so doing, broke the comet up. Didn't have to be much.
So tell us what a coulomb is, if you don't mind.
A coulomb is the amount of electric charge that is moved or held by one volt capacitor. One coulomb is moved at 1 amp through 1 volt. It's basically the amount of charge, the base unit of charge. So a coulomb is obviously where Coulomb's law comes from, but
it's a measurement of charge.
Yeah, basically how many electrons are held into an area, more or less.
Cool beans, thank you.
No problem. So that's why when someone has heat's a form of energy, and you can store that like by, let's say, heating up the floor, and then the ceramic releases it over the course of a day. That's basically equalizing that heat. But equalizing charge doesn't work that way. Charge is it instantly balances. So it's usually a violent thing.
I had this sort of argument with somebody quite recently on a YouTube page, and they were saying that, you know, that plasma is king. I said, well, no, it's movement of charge. There has to be, like, plasma is charge, and if it moves, it's going to create a magnetic field. And the proof of which is capacitors, like you say. If you charge a capacitor, put it on a shelf, you go and try and measure a magnetic field from it, you're not going to get one, because the charges aren't moving.
No.
That's the thing.
Right. And
I pointed him to a few physics papers that expressly state that a fully charged capacitor will not. And then they started bringing out, well, the Earth is moving in relation to. No, we're not talking about things moving. We're talking about movement of charge.
Yeah, I mean, you're not moving a lot through the magnetic field. You're insulated from moving through the sun's magnetic field, so you're not moving on the surface of the Earth. So there might be a wiggle, but you have to overcome a switch. Like, good luck. Like, switches are designed not to, like, it's an open switch. I mean, you have to jump that gap, and unless the dielectric strength is kind of low, which it shouldn't be inside of a capacitor, empty space can basically be a dielectric as well, by the way. So it doesn't have to be air. It doesn't have to be a thing. It could be an empty space, vacuum.
With charged particles in there. Creating one charged particle per square meter is plasma. Considered plasma.
Well, technically, just dust can be a plasma. No, it can be a plasma.
Well, it's a charged
voltage
particle, right?
Well, yeah, basically.
Well, that's anything,
but so does water vapor become charged particles. Like, you know what I mean? Like if you go high enough up, right? So.
Yeah, but that's the definition of the EU definition of plasma is one charged particle per square meter in space.
By the way,
able to allow the charges to flow.
For an interesting aside, James, you brought up, you were talking about dielectrics, obviously. Well, remember how I talked about mica being inside some pyramids in South America or Central America, and one of them was an incredibly large piece, so it had two large pieces of mica, like I think it was 30 feet by 30 feet, and they were about 5 inches thick or something, and they were on top of one another. Now, the reason I bring it up now is because I'm just looking at the dielectric strength. So dielectric strength of vacuum is 20. So that's between like things in space. Air, so it's even a bit better. But when you get to mica, mica is the strongest thing that we have, and it's incredibly resistant to electrical potential. It will not give. It's 5,000. It's like literally 400, or like I don't know how many orders of magnitude, 2 and some odd orders of magnitude stronger than a vacuum. So the top of that pyramid was well insulated from the ground. So, and that's the type of thing that I think about when we look at some of these ancient structures and why they were doing what they were doing. Anyway, things that pop into my brain.
Well, talking about things about popping into your brain is that basically the magnetic fields around the Earth would tell you its structure because, or how many kind of stacked on magnets that you have, because that's the way that it produces its magnetic field. So you could tell whether or not the Earth was completely solid because it would have a specific kind of magnetic field around it. If it's Swiss cheese, it's going to have a different kind of magnetic fields around it. So you can tell what the Earth is.
Well, and you're beginning to see some of the advantages of that and trying to understand things properly. Because we, like you said, I mean, there's only so many ways of seeing inside the planet. And one of them is earthquakes, and the other one is basically using some version of EM waves, trying to understand it through that point of view. So if you don't understand what's going on inside the planet and you think there's a dynamo, you're apt to get things wrong. Yeah.
So, but I'm trying to understand what the hell it was that hit our magnetosphere from the north and disrupted it so heavily. I'm trying to understand what the hell that was,
well,
because we know from mass.
Sorry.
We know from sun ejecting material, flares, and the supposed mass ejections that can occur, that it puts a pressure on our magnetosphere along the ecliptic. But what the hell was it that hit the north of our magnetosphere and just completely disrupted it? That's my question. And that's what I'm interested in trying to figure out.
Well, it didn't disrupt it, obviously, because we're still here. But it
disrupted it temporarily. If you look at MBB3's video, and the goings on, I mean, it did some really weird stuff, making the magnetic field lines go every which way.
Well, like I said, what if it passed through the arm that was connecting between the sun and the Earth, which goes up and out of the planet and then back down to the sun? It doesn't go straight there. So it does make a giant loop. In fact, it's a loop on both sides, really. So.
Well, you know my theory about charged bodies in space relative to each other, and how they situate themselves in the magnetic field lines, or the shells of the magnetic tori that the sun puts out. If a pulse of energy came from the northern Birkeland current that was hit because of an extra pulse of energy coming through one magnetic field line to the next one,
then it would tear off a bunch of material, and that material would eventually travel down that arm towards the North Pole of the Earth.
And then cause a big, huge hit on the magnetic field, right?
And it's just really just a bunch of dust.
Yeah, it's just charged particles.
Yeah.
Yeah.
But they're carrying
it was
charge.
Probably.
Yes.
Yeah, but it was probably forcing a flow that the magnetic field didn't like. It was probably forcing a DC current into an AC circuit, right?
That's not exactly how we describe it. I would think of it more like...
Kind of.
I would think of it more like the current travels instantly, but the particles that were taken off,
well, at light speed, at light speed the current travels, right? Because we know that electrons don't go faster than light speed.
I'm talking about the electric current. Electrons don't have to travel any faster than light speed. The current itself is instant. So, and that's the electric circuit. So the electric circuit would be relatively instant, but the charges that would be drug along by that current, those are the particles of dust that move from the comet down the arm. But I don't know if that's even true. I'm just trying to help you understand.
Wait a second. This is all the micro novas and all this stuff that they're talking about happens every 12,000 years, perfectly, just like the 100 million year perfect cycle of the crust falling into the pot of lava, and all that other good stuff. Now, if in order for, first of all, this disruption.
James, can I just say I love it when you get spicy.
Yeah.
I love it. I love it when you get spicy.
Well, this is just getting nonsense over onto nonsense onto nonsense. There is no microwave flare coming at us, and there's a disruption. So they don't even have. That's not even that. Now, if a microwave micronova happened every 12,000 years, what does a flare got to do with a magnetic field that could be able to flip the Earth? It takes two fields exchanging with each other in order for anybody to, as far as we know.
Well, yeah. Otherwise, they're not interacting, are they? I mean, you just have.
Not only that, every 12,000 years, it didn't flip the Earth. So some flipped and some didn't. And they don't even have any evidence that these flares or microwaves happen. I don't even have any evidence that a nova happened every 12,000 outside of the system, as some are pretending. And they give an exact cycle, 12,068 years, for God's sakes. And with no form of evidence that I know that exists.
If it's a 12,000-year cycle, it should be a 12,500-year cycle-ish, a little bit more than the 68, because of the fact that the great year is 25,960 years, I believe.
Well, yeah, they're
20,
using that.
I think, but it doesn't.
Their argument, though, is, I mean, that it's basically we keep going through these cycles, and they have nothing but we pass through different areas in a cycle, in a cyclic way. Now that we see, especially looking at some of the arguments that we've seen so far, it seems that we're following cycles, but we are moving, like wiggling up a chain. So we
go
not,
into the positive.
The cycles might have similarities, but they might not be exact. Is I guess what I'm saying.
There is one cycle that the great year, which is us going through the ecliptic of the galactic 2 times every 25,900 years.
Like they're going. This is going through the wobble of the Earth, which is I forget
now
how
we're
many
finding
years.
it to be the wobble of the solar system, not the Earth. Yeah.
Well, that's what Yeah. I'm simply saying the origin of it is the wobble of the Earth, and now that they see that this is kind of precession. This is ridiculous. And the ancients, they didn't use the same time cycle. They used a full century, which is like 36,000 years, not the 25,000 years. So.
See the pattern shows this cycle, this 26,000-year cycle, from electric universe perspective on the Birkeland currents. If you go to watch his video, you can see what I'm talking about.
Actually, his argument is actually very strong when you realize that the only reason that precession occurs, according to their reasoning, is due to like a gyroscopic effect, but you need another force, in particular gravity, pulling down on it to get this rotation to occur. Otherwise, gyroscopes are incredibly stable no matter what. So we should keep pointing in the same direction. What seems to be the case is that let's see the pattern, and of course, Jim has pointed out, Jim Weniger, is that you end up with basically the entire solar system like a top snaking along the electric current that is that's basically powering the entire thing.
Because we're in one of the outer shells of a Birkeland current.
Seems,
if we were inside the central, there would be a lot less of that movement going on.
This is where the idea that Sirius is, that's why Sirius is Sirius, because it never, we're looking down at it all the time, and it never moves from the same angle. This is one of the revelations that I think is amazing. So,
go ahead, James.
I have a question for James. I was wondering if, James, given what you shared, it seems to me from the biggest picture perspective that the catastrophe cycle that is being proposed is circular. And in fact, the paradigm of circular cycles is completely debunked by the fact that all of our cycles are spiral, in that they go around and around, but they go around and around in a direction. And so our paradigms have to be thought of in a spiral perspective. And we need to start thinking about circular perspectives like other people think of flat Earth, because a circular perspective is not going to give you anything other than false predictions. And, you know, we've seen people over and over and over and over again rally around the end of the Earth. This is one of the greatest ways to, you know, gather followers that is known to mankind. And I think when we find that people are saying, you know, doom is imminent, this is the foreknown knowledge, I have the secrets of the universe, trust me, I think we have to stop back. And I think that's what you've done. And I think the mechanism for doing it is understanding that all of our solutions and all of our paradigms are spiral, not circular.
Well, actually, that's almost, sorry, James, let me finish that thought, and then you can go. What happened was these events, oscillation of Mars in the polar configuration, coming close to the Earth 12 times, that was predictable, that was cyclical. Mars and Venus orbiting on elongated orbits and intersecting with Earth, that was predictable and cyclical. These things don't happen anymore, and now we're left with only the big cycle stuff, because all of that smaller cycle stuff was interplanetary connections with planets that were a lot closer to us than they are now. Now we're stable, so all of that shit is, you know, if fear mongering is dead in my view. I don't listen to that shit.
Well, I'm suggesting it's nothing more than circular thinking. That, you know, it's the head eats the tail, and so, you know, you're just consuming yourself. I think we have to understand that nature is progress in a cycle, and not in a circle.
Right. Go, James. Go. Sorry, James.
Well,
go.
No. Duffy is right. Is dead right. Is that they actually have 2046 and 2048 as their end dates. That the micro flare is going to happen and it's going to flip the Earth. Well, you know, I'm asking Neil. I mean, you know, hey. Does a flare have whatever it needs to flip the Earth's magnetic pole? I don't think it does. Like I said, you have to have You have to have your own magnetic field come up next to it and exchange with Earth's magnetic field in order for you to do that. And a flare doesn't have that, as far as I can tell, unless there's another kind of phenomenon that would allow a flare coming from the sun to flip the Earth's magnetic poles.
Well, electric currents force.
Can I speak on what Michael said real quick?
Sure.
One sentence. What if cyclicity is bred off of circles and epicycles, and that's most likely how cyclicity comes, so it's all spiral, but the spirals come from circles and circular spherical pressure units.
Toroidals.
That's all.
Yeah, the relationship is inherent, I think, is what you're saying. That circles are in fact, circles are in fact the self-evident symbology of cycles, but they're not in and of themselves a course of action. They're a two-dimensional representation of a thing that exists in multiple dimensions. And the spiral, you know, this toroid, exactly. These are all, classic expressions of that shape. But as far as thinking goes, and as far as how we apply ideas, I think we have to think in terms of there being cyclic change over time, and so I think that explains both how we see things repeating in our world, but we also see the potential for things to be different. In other words, we don't believe in fate, which is a circle, like that it's always going to go back to the beginning. We believe in change over time, but we also see patterns. So that is the nature of the spiral. And I think that from a philosophical perspective, we have to start with the understanding of the circle, which leads us to the process of the cycle. And that is the doing part, and the part that I think that we need to move to, is the idea that the potential for change exists in every scenario. And that's because we live in a cycle, not in a circle. So that's just my sort of big picture idea of it.
Yeah, the thing of it is that if you're going to have a 12,000 year cycle, then you better have a model for that, because you don't have any historical dates. You don't have any, all you've got is the Earth is had its things, and like I said, it sometimes it reverses and sometimes it doesn't. It didn't in well, I forget whether it was disruption or reversal. They say 72,000 years ago. Now, the 60,000 year reversal was real, and the 45,000 and not 48,000 year reversal is real. And then there's another one about 38,000 that's real. But then after that, it's a game. It's not 36,000. It's 34,000, and it was a disruption. It was not a reversal. And then there's 23,000, and not 24,000, and that was a disruption, and it's not. And then the last one's supposed to be 12,000. Of course, it's the 11,700 year thing, and it's considered by the establishment a reversal, but I think it's actually a disruption. That in some parts the tilt changed, so you could get a reverse polar on certain areas. But that's just my thing. Even if you take 12,000 as a reversal, not all of them are, and they're not 12,000 a cycle, and maybe So to say that you can predict in 2046 or 2048 is just nonsense.
No,
and I'm
fear mongering is very saleable, unfortunately.
Yeah.
Well, that's what followers.
What's really sad is they may be able to predict a tendency, but then selling it as a prophecy waters down any relevant information that could have been gathered. So. Again, it's the truth for sale. It becomes sort of like truth for power's sake.
Well, yeah, if I wanted to make money off of this, I would totally go into preaching a Giza power plant and talk about aliens and spirituality or something, and then
hit me on the privates later. We'll
sell crystals. Something. Yeah, exactly. Yeah, we'll get a whole thing going on.
You and I need to be more cutthroat, I think.
I know, eh? Jeez.
We're just ridiculously too considerate of others, I think.
Well, I want people to, have their own passions, and I'm glad that they got led to the electric universe, and hopefully we can help answer a bunch of questions, or to put more education in their brain, so to speak, and hopefully answer a few of these gnawing problems. But I don't think the world's suddenly going to end. I'm quite surprised at the amount of crap that we went through and are still here, and it's quite possible that we are living in a post-apocalyptic society whose mechanisms are have been gone for over 6,000 years. That's very interesting and intriguing to me. But no, I don't think there's aliens, and I don't think that I have the answers to everything, or that things are suddenly the world is going to end and a giant Planet 9 is going to hit us or something. I don't see that happening.
See, I keep aliens in my maybe file.
Well, sure, of course they're maybe. You have to be maybe.
Yeah, they're not in my for sure file at all, because I think the potential to use the alien phenomenon for very very real human gain is ever present. But they're in my maybe file, you know, and
well, heck, the universe being alive
you know,
in a giant brain is in my maybe file. So
yeah, I think we should all, exactly. That's kind of my bigger point. Is I think we should all have a maybe file. You need to be able to consider. Yeah, there needs to be stuff that you're kicking around in your brain all the time. You know, as far as I'm concerned, that's sort of like the enlightenment. Really,
and you
is
have
that
to be
ability
able to
sort of ponder.
Yeah, you have to be able to stop and to go, okay. Like I was totally on board 100% with all of the Argo and the Whirlpool and everything being part of the Saturn myth until Jim came along and was like, no, this much more fits this idea of the Pleiades and all that stuff. And I was like, holy crap, it does. Well, now I have to think about this, right? Like, is it bigger than just Saturn? Like, was there other things going on for God knows how long? Like, when I look at those Paracas skulls now, I think this is probably just literally like Neanderthals or people before us who were literally, we thought of them as people, not creatures, you know, and we revered them. Like, I mean, that has more merit to me than to think of them as aliens, for example. But it also puts us in a long history, like where the world has a much longer history than we like to think it does. Like civilization could be hundreds of thousands of years old, you know.
Okay, Neil, so check this out.
Okay.
The only thing that really is bugging me right now about the comet or whatever it was, a comet is what we're calling it, right?
We'll call it a comet, sure, why not?
Okay, we don't necessarily, but it's whatever it was. So the only thing that's really bothering me is the time frame between us discovering it and it disappearing. So that's weird. Statistically speaking, like chances of us just discovering it, like within what, I don't know, a month, a few weeks of it being discovered, it just suddenly just exploded. Which brings me to my favorite alien conspiracy, that the Earth is a seed bank, that the Earth is a garden planet, and that we are in fact protected from a distance, like in the beautiful song by
the day the universe stood still, the day the world stood still.
God is watching us from a distance. That's it. That's all I wanted to say. No, but seriously, that's my real question. The time span between us discovering it and it becoming and just exploding for some reason that you've attempted to explain potentially, it's just a very short. Like this thing's floating around for what, billions of years or hundreds of thousands of years or whatever, and then we discover it, and a week later it's gone. Like that, that just seems weird timing wise.
Well, actually, we probably had, like, the first time that we knew that comets came back was Comet Halley, really. So we don't, before that, they were not mapped or anything like that. And when they came in, there could have been a lot of them exploded as they came by the sun. As far as we know, it's a fairly common occurrence.
How do we know this is the way it always happens? Yeah, I guess. Well, and I did read somewhere briefly that it's believed that this may have been a comet that we'd seen previously, that it was connected with a comet that was seen in the sometime hundreds of years ago or something.
That wouldn't surprise me.
I don't know that I don't know how much data there is on that, but there's a lot of speculation out there. Well, I just think the timing is weird.
That's the thing about the force that we're talking about is there's a attractive and repulsive type of force that goes with it, but there's also a torque that goes with it, a spinning, and that is something that like when you're talking about moving things, like in flipping planets and stuff like that. I mean, to flip a planet, you'd have to have a torque put on the planet by a body that would not move, like Jupiter or something that would easily flip us over to a line with its polarity.
For lack of a...
Yeah, or I now that's of course not something that I'm advocating or anything, but that's the only way I could picture it, because it would, it would not want to be out of alignment with what it is. But the trouble is that the Earth itself, I think its field is induced. So if its field is induced, then there's nothing grabbing a hold of the inside of the Earth like a real bar magnet would. A bar magnet would go, oh, I'm flipping because you've changed the polarity. I'm going to flip that way. Oh, you changed it? I'm flipping it again. That right there is the basis for the first computers on board the Saturn V rocket, was just basically using magnetic fields as ones and zeros, which was hilarious when you think about it. But the that polarity is, if the Earth is generating its field, then all it would do would we simply go, oh, you've changed polarity. Okay, I will now flow in that direction. Thanks. It doesn't have to flip the Earth. It just has to change its direction of flow, and it's fine with that. So this is I mean, it's easier than flipping a planet, is what I'm saying. So.
Lists of things that are easier than flipping a planet.
I'm now thinking of Samantha Carter there. What was it? Sam Carter was like, you blow up one sun and people expect you to walk on water.
But what I hear you saying is in order for the change to happen in the way that there has to be something against which it changes.
Yes.
Is what you're kind of saying, right?
Yeah, and it's easy to
like
believe.
In space, there has to be a thing that you move against in order there to be the potential for movement.
Right, and that's what we noticed when we launched a nuclear bomb and exploded it in space. We expected to see a special effect from Star Wars with a huge explosion, right? That's not what happened at all. It basically started it gave off all of these EM waves, and all of the particles started moving through the magnetic field of the Earth. So that was the easiest thing for it to do. It didn't explode radially. It exploded north and south along the field lines and created a giant fin in the sky. And that, an artificial aurora, basically. So that is because that's the easiest thing for them to do in that field. So that's downhill to that field. And the explosion itself is not, there was nothing to push against it, right? It was just literally just a big poof. Well, all that charge that was generated by that, which was literally insurmountable amounts of charge, well, actually not insurmountable, gigatons, but it had to be bled off, and it was bled off by going through the magnetic field. And so it just started spiraling through it and making it glow. And that's how that stuff really works. It's not it has to, so the same thing is when this thing's traveling through space, the current is doing something completely different than the physical object as it's doing. I mean, if it gets too close to something, it's going to pop, it will break into pieces, stuff like that. The Earth itself, of course, is obviously incredibly round, so it's not, that type of thing doesn't happen to us very much. We need a lot more power to make something like that happen to us. But to little rocks that are being influenced by giant bodies with so many more coulombs than they have. It's like, I have, 100,000 coulombs. It goes like, I have 2.5 billion pop, give me your electrons, please. I'm not even saying please, I'm just going to take your electrons.
So in the end, you're saying really it's a completely explainable phenomenon. Yeah. You're not necessarily saying this is absolutely what happened, but it's easily explainable given our current knowledge of the nature and lifespans of comets, that it would just sort of spontaneously combust.
Yeah.
Given the parameters that you're suggesting,
especially
it's not
since
completely
its coma is very large. I mean, it was coming in with a large coma. That means it had a lot of electrical potential. And as it got closer, the coma would start shrinking down as it gets closer and closer, and maybe it touched something, and sure, yeah, traveling, going, oh, okay, well, now that this is a lot of potential here, I will ask for more electrons out of this side of the comet. Okay, I just made a little crater on the comet, and now pieces are flying off of it. Oh, it broke into several pieces, okay. and the electrons are still traveling down to wherever they're going, following the current. And you know, we happen to get hit with a little bit on the north part of our magnetic field, and we feel that because we sense it. But that's really it. That's what it feel. I mean, that's what I would explain it that way. But that's, you know, an explanation without merit because I didn't really investigate it. So, but clearly
you're
nothing.
Spitballing to a degree, but given your current understanding, it makes sense. You know, I mean, if just entertaining the idea that it literally is just a natural phenomenon in the sky, it's also a stroke of amazing luck, I think. And you know, it could be seen from a betting man's perspective as a good luck omen. You know, the comet that didn't kill us. We should be maybe thankful. I don't know. Like I'm looking for hope wherever I can find it. So you know, what the heck.
This they don't show this. If you actually look at the real footage of this is probably the most revealing. This is I'm just showing footage of Comet Temple 1, which was the Stardust flyby of the comet. Anyway, we threw an impactor towards Comet Temple 1 at a distance, 112 miles away, but we were hitting the comet at 24,000 miles an hour. And we're going to use the footage to see what they got out of this. But what happened was, if you look at the actual, like as it gets closer and closer, if you actually look at the actual footage, which they don't show you, you have to actually find the real footage, and I'm looking for it. The reason is because the impactor had a huge torque put on it at 7 miles. So the comet no longer was, like, as it was traveling towards the comet, the impactor had a camera on it, and it suddenly, at a distance of 7 miles from the comet, had a huge twist and turned, which, in my opinion, was that exact force of torque on that body. It basically said, oh, okay, and that's one of the forces. It can't repel it, but it can twist it. Current will give a twist as it goes through. Which is, of course, basic right-hand rule stuff. So that's what I think, but finding the actual footage for that is difficult, to say the least. I'm trying to find the actual footage, because it's a bit of a... They only show the actual still photos. You know what I mean? But anyway. Please continue, guys. I'm sorry.
So, I wonder what our friend Tess would say about the relationship between comets and pandemics.
I would agree the same as Fred Hoyle would say, probably.
I don't know. I mean, there's certainly the parallels that could be made. I don't. I mean, it's a parallel without a purpose, I guess. I mean, unless there can be some connection made, but it's an interesting idea.
Well, I mean, we were talking about the, I mean, the idea that Venus created a bunch of viruses is not new. And obviously heavenly bodies were also thought to do this all the time. So, now I don't know how true that is, of course, but let me... take a look if I can see when did well, I was suddenly going to start researching when COVID started, and then then suddenly realized when did Venus last approach us? Let's take a look. Closest approach, Earth. All right. You don't have to, like, not talk. I'm sorry. I'm looking things up, and I'm probably very boring to the people online.
Well, if you're looking for Comets, I mean, they've actually found that there was actually some data and some understanding about it in September. So, and we knew about it in November. Our spies knew about it in November. It became pathetically, ridiculously obvious in December in China.
Yeah,
so that they finally got to using tests, and they did things real, and then their doctors and nurses didn't die because they actually used the protections that we don't have and the tests that we don't have in the United States, at least. So, I mean, if you're going to go from September to now, you're covered almost the whole year, so you can get Venus in there somewhere. You know,
well, that's what I mean. Like, I don't want to make stuff up here.
The optimist.
Yeah.
Any time of the year that you want to stick it, you're going to start putting it. Oh, it happened here, or you know. So you're covering up so much. That's the other thing about it's like even in gravity theory, all the asteroids and stuff are around. They're all going to fall into the sun, Jupiter and Saturn in 40 to 50,000 years. All of the stuff. So all of that stuff is new. And then you go to mankind with Churchward. When I was a kid and I read that, he said the first civilization was 200,000 years ago. And everybody poo-hooed that until their DNA said, "Oh yeah, modern man."
I mean, it makes perfect sense that it's something. I mean, they talk about how much wear and tear there was on Stonehenge alone. I thought that was very interesting because well, it just seems to have a lot of wear on it. That's all. But anyway, keep going.
Well, I mean, they just poo-hooed Churchward when he said that, and then our DNA proves that modern mankind, is no more than 200,000 years old, right on the dot. You know, it's just for goodness sakes.
I think that's using mitochondrial DNA with.
No, it's all for 90% of all animals are only 200,000 years, including mankind, not modern mankind. There's just no question.
That just means that 200,000 years ago, something horrible happened that almost killed every single thing on the planet, probably.
Or
well, no, they talk about like the possibility, like if Venus, or if an encounter happened where there was because remember there was this every so many 26 million years there was a massive extinction, and some argue, well, that's Saturn coming back and forth type of thing, and then of course then it was slowing down as it kept getting closer and closer, and but I don't know for sure. I just picture that kind of stuff.
Yeah. The thing of it is that, well, not the thing, but you have to know your timetable for sure, and they don't, not even close, because it's all built up on the timetable of how old the Earth is, and that's how the shape of it is, and it's this melting pot of lava that doesn't exist, and on and on and on and on and on. It's just like they're. I don't know what they're doing. They're fantasizing things, and then they're trying to make them real. It's just like the wobble, the 26,000 year, 25,920, I think it is, number of years of the wobble. Well, the wobble hasn't been stable, nor has the Earth's orbit been stable, nor has the inclination of the Earth been the same in historical times, for goodness sakes, and yet they pretend in this double-mindedness of the Earth has been exactly as it has been today for millions and billions of years, and it's all nonsense. We have historical evidence that it was different, but they refuse to look at it. They refuse to open up their minds to see that the wobble wasn't the same, the inclination wasn't the same, even the orbit itself was not the same, and the moon going around the Earth has not been the same since the 7th or 8th century, the Common Era. And to say that they know the cycle is like say without knowing. They're using different measurements for the reversals. The reversals are using the archaeological dating of a 1,000 years per foot. That's not what the geology is doing at all. In fact, I haven't been able to figure out. You can't have miles per level, and there's only 18 on the entirety of the crust, which is like 95 million years by the archaeological measure. And they're using, I don't know what they're using. I don't know how they take it like each level is like its own kingdom, and but you can't put them together because it would be more than 18 miles. I mean, heck, 3 or 4 of those levels would be more than 18 miles the way that they're measuring it. I'm ignorant in geology. I admit that. I don't know what they're doing. I don't know how they're doing it, but if you're going to go by the Grand Canyon scale, it's not even close to what they're doing. And like I said, even the reversals in their measurements are in feet. The 45,000 years ago reversal is 45 feet down. And the same for the 60 is 60 feet down. It's not what they're going through. And if you want to say that something's a particular cycle, then you're going to have to go throughout the entire layer, and they don't do that. They're going as further as more than 72,000 years, they say. And that's 72 feet. That's not miles.
Yeah, well,
it's not even scratching in it. It's not doing anything. They're so disconnected from each other, each of those fields, that I don't see how they can say that they have any connectivity to them at all. Thank you very much.
Oh, I'm sorry for losing a little bit of you there.
That was the mic drop.
Yeah, I know, eh? I'm sorry for not recording the whole thing because I dropped out there. So we might have to be careful because I think I might have to cut it a bit short. But still, this, did you see what Chris put down there? It's like October 22nd, 1962. They fused 570 kilometers of overhead telephone line with a measured current of 2,500 amps because they did a high altitude test over the area. That's, well, there's a lot of power, and suddenly you were crossing with all these lines, these electrical cords, which if you actually look at the reason that happened, actually, Chris, just the reason I'm so excited about hearing about that is because if you watch Walter Lewin from MIT, on his very first thing, he says it doesn't matter how big the loops are. It's just that the math is the same no matter what. So if you have a giant loop, like, for example, say from Moscow down to wherever, all the way around and then back up, and then suddenly you launch or you blow up a nuclear bomb, well, a bunch of current is now going to be traveling through that wire as a ring current. So just very interesting that sort of thing. I didn't know that happened. That's 2,500 amps. That'll take care of it during over a telephone line. Jesus. just the explosion waiting to happen. Still.
Doesn't that mean that by this micro flare thing that they should be able to reverse the Earth through that method? Reverse the Earth's poles by that method?
Well, it depends. If the reason for the pole has to do with the current traveling into the pole, then the reason that we're losing our magnetic field would be because the current is hitting equilibrium. Because the potential has to do with one side over the other side. So you would have more current coming in the South Pole, which would give us, would make that the quote-unquote North Pole, which is why anyway, it's just the way that in essence, though, the current that is traveling through the planet, once it equalizes, we will have a very weak North and South Pole. But eventually, it would flip then at that point. Not physically, but the current would start being stronger in the North Pole, and all of our compasses would flip direction. But all that would happen from the electric field or the magnetic field would begin to spiral back up again. But just in the polarities wouldn't really change, just the overall polarity of the planet. But we still have lots of little secondary circuits that would not change. So. And the electric field would not go
just
away.
like the sun.
Yeah, basically.
Like the sun flips.
Exactly. For the exact same reasons.
I'm having a hard time. I'm having conversations in the live chat like crazy, and listening to you guys and throwing in every once in a while here. Wow. Somebody
so let's talk about the Ebner effect.
Somebody stop it. Either you guys or these guys. I don't know, man. I'm getting overloaded.
Well, okay. Well, tell us what. Maybe there's something we can help with.
I'm joking.
Can we talk about
Come
the
on.
Ebner effect?
Oh.
Yes, I would say so.
I think that's the most interesting topic in the chat right now is the Ebner effect.
The basically electrifying plants or seeds and making them grow and then seeing what they turn into.
Yeah, and potential of incremental changes over geologic time, compounded with differences between species. It's the effect of electric, basically, influence over genetics.
Oh yes, that's like, I mean, I think they could explain a lot of things. I used to think it was the answer for everything, but I've recently realized it has a lot to do with probably strength and size and construction, but not necessarily it has to do with adaptability, but not the origin of the creature, I guess. You know what I mean? Like it'll show how it develops as opposed to what it is. That makes sense.
Well, isn't it? Wouldn't you think it's one of the ways that we express our genetics in the context of our environment? That our genetics has the capacity to express itself in several different, I want to say derivations, but expressions or outcomes, and that our environment actually dictates kind of, whether or not we get fins or whatever. I don't know. Like, is it they're sort of an on-off feature, and there's a lot of just sort of like dead code or non-functioning code within our DNA, and I certainly would make sense that there would be a way to turn those things on and off.
Well, it seems that it happens all the time, like and faster than we thought. Like there was this famous swimmer. Well, actually, I don't know how famous she is, but she was a cold water swimmer who used to do ice runs, and she developed a layer of fat over her entire body. And
yes, sir. I believe that too.
And her daughter has it now. That's just one generation.
Yeah, she passed it on sexually. The daughter didn't develop this herself. It was passed on through the genes that were changed because of the change in environment. Yes, environmental effects can change things, and we know from science. We were just having this discussion. We know from science that electricity itself can make changes to DNA. Period.
I did not know that. Well, I mean, I figured. I didn't know
they're using an electrostatic field.
There's science papers on it.
We definitely.
Swiss scientists are using an electrostatic field that fish eggs plants are germinated in an electrostatic field and alters in the electrostatic field that they're grown in. Once the fetal stage was over, they were then able to transplant the plants and move the fish away from the ESF, and they continue to grow in their new forms. The fish that were grown looked like 150-year-old extinct species of fish. The plants also very odd, with corn having 8 heads instead of 1, and wheat being ready to harvest in 10 weeks.
Reverting back to the natural state, reverting back to the state that they were before the change, these thunderbolts of the gods that came and slammed into this planet and caused major changes to the people, the animals, and the geology of this earth.
Hold on. Let's not.
By the way, I also have 8 heads in my natural state, so
I'm just saying I have 8 tentacles, so it's understandable. So I guess hail octopus, hail nobra, or hydra, or whatever. Anyway, so the thing though is that when you say electrostatic field, in actuality, the way you make an electrostatic field is with a capacitor. So, and to say that the Earth is a capacitor, that's exactly what I'm saying. So, if the Earth was in a field that was stronger, for example, and the ionosphere was pulled down towards the Earth, or pushed down, whatever you want to call it, and the voltage is higher than it is now, then that would be a higher electrostatic field. And so maybe that would explain why they grew into those types, because it was a stronger field and it grew into those types.
Well, the Earth certainly has a natural electrostatic field, of course.
Yes.
As you say. What's interesting here is that we can now prove in the lab that genetic changes and dramatic variations in response to these changes can happen over a single generation.
Mm-hmm.
This isn't like long, slow change. This is, just like a lot of things we are learning. It's happening.
What if we applied that same process to an elephant's egg? Would we get a mammoth?
Now you're talking.
We might, or we might just get a pink elephant.
But here's the problem.
Well, I mean, you have to do a lot of drinking.
Let us not dwell too much, though. We got to understand also is that as much as we'd like to think that there are just furry elephants, they are much larger than elephants. So.
Well, yeah, I understand that. I was the one that mentioned that CPAPPS 567, the history guy that I subbed to, his video, he said on the video, one of the ancient American myths and legends is all the big animals walked into a tent, and on the other side they came out smaller. Wow, that's a metaphor for something happened.
Girl, that's a diet
Something
plan.
big happened.
Interestingly, by the way, the tent, that all the animals went through, the original Noah's Ark was a pyramid that launched from the top of the planet and then sailed, which would, if it was Saturn, that makes sense, sailed away. Now, the animals that went with it in that story, it's odd that you had mentioned that they would go through that same story to a similar place. So maybe there was something to sort of like imply that something that looked like animals, perhaps like things with horns, are traveling towards the North Pole before this event, as this event was occurring. I don't know.
I think they were referring to the physical animals on the planet that they said the big animals, the big bad animals, went into the tent, and they came out smaller on the other side.
No. I'm not arguing that. I'm not arguing
I can only interpret that one way.
Yeah, well, I can interpret it by stories that we told like later, but still, the argument is that they both have, even the Epic of Gilgamesh and the story of Noah and this story all have pyramids in it, or teepees, or tent. Okay, and the animals being gathered is another similarity. Okay, now they go there in one, but they're being drawn there by Noah and his family in another one, or Gilgamesh in another one. All I'm saying is that they could be related as a story. Now, as later when the story is told, because this would be generations, yeah, all the animals are smaller now, which is what would happen.
Well, they gathered in the only warmest place on the planet, which was the North Pole at the time, because everything else was frozen as we were coming into the solar system.
Okay, that's not my interpretation, but I suppose that could be a case.
Well, South American Codex state people were freezing. They asked the king for food. He denied them. And the king watched people die all around him because South America was frozen? What?
Well, I've watched, I know the story of King Arthur. I mean, Patrick Stewart's in it.
No, for a number of years, South America went through a freezing period, and there's evidence of glacial action everywhere on the planet, even in the Caribbean, around the equator. There's glacial action everywhere.
Well, okay, you got to take a step back there, only because the definitions of glacial action are glacial erratics, concretions, and other things that more than likely are electrical in nature. We do know that, for example, glacial trenches are electrical now. So we have to re-examine a lot of this stuff. I'm not saying you're wrong, though.
They're examining features that they see from retreating glaciers and things like that, like erratics, like you say. And they're determining that there's been glacial action everywhere around the globe. Everywhere. Every landmass has experienced ice.
I have no doubt that's the case.
And lots of it.
Still,
and
impressive.
If Saturn's purple dawn had dropped, it would have taken a number of years for us to travel the distance from the outer regions of the sun's magnetic field from the southern pole region into the inner solar system along with Saturn. And Saturn wouldn't have been able to supply the amount of heat that it was doing before, as it was turned off as the sun and the corona had dropped and we were inside the corona.
Well, that's assuming
so
that's
it makes
the way
all perfect sense to me.
Well, yeah, it can, and I have no argument with that, but also I can also see it another way, where we were grabbed by Saturn when it came back in and pulled us around into an orbit around it, and as we went around it, we went behind this gas giant, and suddenly we were no longer in the presence of the sun. I'm not saying that exactly happened. I'm just giving you an example of different ways the planet can get dark. So I'm just saying, keep an open mind.
Right, yeah, eclipses, yeah, I understand. But, that's not...
I agree the story is real, though. Because I don't know, but I also know there's a Norse version of it. But anyway, back to the overall thing. Like I said, I found that the pyramid or tent idea and the animals going into it being a very interesting link between two different cultures.
Well, maybe this tent was the tent of Enlil, the mountain of water that was visible, and they all walked up towards it because it was the only place that was warm.
I mean, that's, in fact, did you, I think well, you might not have been present to this, but we were talking about these man-made islands out in the water that then you have a bunch of a rocky trail that leads
off of Dubai.
No, these are not in Dubai. These are in Ireland and stuff like that.
Okay.
So they.
Oh, right, yeah, yes.
Yeah, and they're like, and so it's interesting because we were talking about barrows and other things. Like barrows are let's go underground and up through the tunnel and talk to the god, and this one's more of a let's build towards the god out on the water, like it's sticking up and out of the water or through the north of the planet, and looking like a connection thing. That we build something similar to that out on the water, and they couldn't figure out why they were putting so much effort into it. And of course, how could you, I mean, if that's the type of society you're in, I mean, this is like building like pyramids to gods, you don't shirk on your duties to that, I guess. Man-made islands, I'm looking for those. Man-made island. Cranogs, that's what they're called.
Yes, sir. I remember watching a video of Scottish Cranog.
Yeah, look at that. Look at it. A Scottish Cranog is literally a teepee giant mountain. I didn't know that at all. Well, geez.
Out in the middle of water,
standing
on
water, standing in
holes.
Yeah. Wow. Now I know, eh?
Pillars.
Oh, it's just amazing that they did this. I mean, and of course, it would. Remember, a lot of times these people didn't have perspective. I know that sounds, I'm being really cruel, but some of these people were not conscious, if that's the case. And have you've seen those examples of people who are from, I don't want to say uncontacted tribes, but more sheltered tribes in Africa, and for example, some that have never been outside of jungle areas, and they did not have any perception, like a depth perception, like a fly on the window was giant to them. You know what I mean? Because they never saw things that far away before, like out across the savannah. So it's very interesting how some of these situations.
Right, and it was a nice fact that when they built these out over the water, they got away from the bugs. The bugs weren't as bad out there on the water because the wind is just going across the water and there's not being caught into the trees and disturbing the leaves and kicking the bugs off, and then they're looking for food and you.
Oh,
go ahead, sir.
I was simply imagining that you're standing there on the shore, right, and then you see you stand at a particular place at the end of where the dock is, right, and then it has a pyramid shape to it, a tent shape, and so it's positioned in the perfect spot, so it's sort of like it's hovering there. Like, yeah, exactly. It would have a thing hovering over the middle of it in the sky. And then you would travel down that dock, and the perception would be that you're traveling towards that object, just like they did in
Stairway to Heaven.
Exactly, just like they did in Tenochtitlan in Mexico City. There, those type of pyramids where you walk up the front of it. As long as you're standing in the middle of it, the illusion will be satisfied. If you know what I mean.
Yes, sir. I know exactly what you mean.
I just found it interesting. I don't know if it's true. I just could envision it, given the circumstances. I mean, we've seen a lot of these. Go ahead.
This sounds like a central mount there, and that like Stonehenge with the 56 things around it, and it digs out the center. I mean, it digs out there around, but not the center. And like the machining that it leaves that central mound in the middle of it. So maybe they were just reflecting that, because they did. I think the Mongolians did the same thing with their burial grounds. They had the flags around the center of it.
Oh yes, for sure. I know of
probably
several
56 of them.
Several structures that are like that, for sure. We have, obviously, even here in Ohio, they giant mound pyramids. I think that sometimes they're trying to imitate different types. They have poles that will imitate it, depending. Some are called the anchor of the world. There's one in Wyoming. Look at this one. I didn't even notice this one. I'm gonna Open the image in a new tab. Okay.
I heart you.
Yeah, I saw that too. Here, look at this. There for out in the middle of Wyoming. There's a Stonehenge. I didn't even know. I mean, it's even Saturnian. I mean, look at all the things on the ground and everything. The marks.
Well, CPA 5978 whatever is putting out 2 videos a day, so I watch his stuff religious like.
I wonder, maybe there's 56 of those streamers out there.
Well, that's what I'm saying. And one of the things that I'm thinking about when I look at this is, like, now because of what we've talked about with regards to Jim's work and stuff, I try to sometimes envision that this is not Saturn, but this is looking up the arm of the galaxy or something, or the local chimney. You're looking up towards, perhaps towards Sirius or whatever, and that's what I'm looking at. And that these around the edge are all perhaps different solar systems that we can see now. Now, I don't know if this, I'm not remotely thinking that this is necessarily true, but to do justice to Jim, I do try to think about this from time to time to try to insert these new interpretations, because obviously if we could see the entire local chimney as if it was on fire, it would be something spectacular. I don't know if that's true or not, but you see what I mean?
Well, it looks like Le Parade instability from looking down the barrel of it.
I totally agree. It much more likely is from our planet, but I'm just trying to be, thoughtful.
Well, yeah, I mean, you have to explore all angles. If you don't ask questions and you stick to a theory 100%, and you fall into a trap. So yeah, exactly. I mean, you have to be open-minded for sure.
Some of these are very beautiful, and it's nice now that we're looking at some of these places. I mean, like, why did they build underneath the ledge of a cave? Like why did they have a cliff over top of them? And you're like, because they didn't want to get hit by lightning. Like, I mean, I'm just looking at some of these pictures and seeing, like, just here, if I can open it. Open image in new tab. There we go. There. See what I mean? Like this one here. Like, why were they building there? They were protecting themselves from rain? Maybe not. Maybe just because they didn't want to get hit by lightning. And I notice a lot of things, like, they have these structures that are particularly strong. Like you were prepared for dangerous things above your head, like giant rocks falling and stuff. Anyway, just some thoughts.
Well, Ray Carr asked if I could post a link. I'm not sure what he was talking about. Maybe he was talking about what you were just showing there in Montana, I think it is.
Well, actually, only certain people can get links, but he could send it privately to you, and you could send it to us.
No, if you could post it in, like you to post the link that you were looking at, that stone circle. I think that's what he was referring to. If you could post it in the live chat, that would be great.
Well, I can't.
Okay.
Because I no longer have access to the chat, but you can.
Can you post it in Skype, and then I'll post it in the live chat? Skype. Oh, look at that! See? I'm so dumb.
No, not dumb. Just okay, dumb. Okay, dumb. Sorry.
Okay, he just said the YouTuber I've been talking about. I think it was talking about Kronos. No, I'm not sure what he's referring to.
He wasn't even talking to you. Oh, shockwave.
No, I was talking to Ray Carr, and he was asking to post a link, and I was saying, okay, I think he's talking about the link that Neil was just showing.
Will Riker or Thomas Riker?
William Riker.
Okay. I want to make sure. One stole the Defiant, I think, didn't he? For the Maquis? That's all I remember. Weird beard. That's what I remember. They're called.
Careful now. I'm very pro beard.
You're very pro beard.
I see you. I'm literally watching you play with your beard.
I know.
Right now.
The whole time I've been playing with it because it's getting long,
right?
and I'm just.
So
I can't stop.
Don't even start talking trash about the beards.
I can't.
No, you're not. You don't have that kind of cred. You're one of us, bro.
There's Tess. She just showed up
in
the live chat.
I'm just looking at some of these wonderful pieces of look like protective culture of dolmens and stuff like that. Only because I still get stunned about how, like, why would you build them? And I keep on thinking about why, like, what were you trying to protect yourself from? And it's certainly not animals. I mean, I didn't even notice this. Did you notice this at Easter Island? I never even noticed this before. Like, they tell you how old Easter Island is. They say, oh yeah, it's only 400 years old or something. Did you? I mean, look at that. I mean, that is literally. Oh, there's my hard drive. Literally, a squatter man sitting right there, giving the age of this stuff to be way older than 400 years. I think it's 400 years just to make us feel good about the fact that we were pillaging their culture.
Well, I forget that the water rose 12,000 years ago, and there's a lot of stuff under the water, probably around Easter Island that nobody's even discovered yet. So
I don't know.
Guess
for
what?
Sure.
That's way older.
Yeah.
Well, I'm sure there is. I mean, 400 feet of sea level rise in a 1,200-year period. Two pulses that science has figured out, pulse meltwater 1A and pulse meltwater 1B, took place about 1,200 years apart. First one melted a good chunk of the ice cap, and then the second one did the same. How did that happen? What caused it? Randall Carlson says comets impacted. No, I'm not so sure they have enough energy. I'm pretty damn sure that they don't have enough energy to melt that much water in one shot. And I know that Thunderbolts of the gods do.
I think the Karnak stones are probably my favorite because they were so ambitious. I mean, there are literally thousands of them all in rows. And I think they use that likes principle to communicate, or otherwise, because if each one of them is charged, then the space between them is not charged. You know what I mean? Like it's charged in the opposite polarity. And so you have basically a coma and then a space, a coma and a space. So you could effectively basically make a wiggle one end and then it would go all the way down the line. You know what I mean? I picture them doing that from the coast all the way down, because I mean these things go all the way from the coast of France down in the middle of France. So I mean, what are these, the ancient version of telephone lines or something? No. Hey everyone, there's a tsunami coming. What's the last word he said? He said his last words were glurg, glurg, glurg. Oh, we better
you sure it wasn't blub blub blub?
Blub blub blub. Well, it depends. I mean, it depends on what they glurg.
It's a regional. It's a dialect issue.
That's a good one. That like some of these dolmens are longer than others. I didn't know that.
Well, if you had to fit a family in there instead of just 2 or 3 people.
Well, the thing was that there wasn't a lot of supplies. It's like they were basically knew that these storms or whatever they were running from didn't last long, and they needed tough cover, but they didn't need supplies. That's the biggest thing that I've learned from that.
Yeah,
it seems to be where you would like, all right, everyone get in there, quick, get the animals in, quick. All right, now we're gonna sit here for the next
day or so.
Yeah. and then we're going to come out. We're going to be hungry, but we are not going to be dead. So, win.
Because we know, we understand that these thunderbolts probably act within a 24-ish hour period, maybe less, maybe more.
Well, I think it's like storms today. Like, I mean, we have a storm today. It's just they were more powerful.
When the planet gets to a certain distance, off goes the charge, and then away starts the planet's movement again in the opposite direction because of that exchange of charge. Velikovsky, right?
Now I'm wondering about these ones. Look at these giant buckets. Did they jump inside those?
Well, they probably had stone roof on top of that, right?
Oh, it's just a thought. They look like more like storage containers the way they are made, but they're so big.
Well, a storage container with a hole in the side of it in each compartment, I don't think would work very well.
Probably not.
Person could crawl through there into the back chamber. Yeah.
I like some of the work on this one, for example. You can see the waves, just like
Oh, wait a second! I just figured that out. That's over time. The first was cut into the hill, and the second, as more people knew about this spot, they had to extend it out further and further. They cut a hole in the center, so the first people in could make their way to the back, so the other people could get in.
That wouldn't surprise me. That wouldn't surprise me. It's like, and these are the first inns that ever were built. They had
later home editions.
Yeah.
Or bunker editions.
Well, I mean, if we were mostly nomadic and following food, then because there was a lot of food to hunt, then that makes perfect sense that you would just simply need a place to lie low and get shelter. Whenever
for about a 24-hour, maybe 48-hour period, while the planet just started to go away after the Thunderbolt was exchanged.
And then you go and because all you need is protection from rain and stuff. So you just, throw up your teepee type of thing, right?
Right.
Anyway, just very interesting. And obviously when it gets to stuff in Japan and stuff, I mean, you end up being in a whole different world. Blows my mind every time.
Where have we seen that zigzag pattern before? Oh yeah.
Oh yeah.
The ladder to heaven. Wow. Okay.
Exactly.
And it's worldwide, folks. I mean, it's in Japan. It's in South America. It's in Middle East. It's every freaking where. Just the same as the polar configuration of planets, Saturn being the big circle, the flower or the star in the center is Venus, and I is Mars. Some cultures made Mars when it started after the birth of Venus, when it started its multiple approaches to Earth. Guess what, folks? Due to perception, Mars became bigger than Saturn, larger than Saturn because of its close approach, because of perception. Guess what? Mars became the main god for the Egyptian peoples at one point, not Saturn. They changed.
Well, yeah.
These gods were interchangeable for them.
Well, whichever one was threatening to kill you would be the one you'd sacrifice virgins to, right?
Or deify as the main god for a little while.
Well,
yeah.
I'm not really big on the virgin sacrifice thing, but I'll take it from people who know.
I didn't want to go there. I was trying to stay away from there.
I'm not really big on the virgin sacrifice thing. Me either.
But I've watched. No, I watched the movie. I watched that movie. What was it? The original Clash of the Titans with the mechanical owl and the Perseus and Medusa in there. And there was a Kraken that was. He was chained up or something. I remember at the very beginning, and she was screaming there, and yeah.
Perseus I do love a mechanical owl.
God, I love that owl. I don't know why they didn't put it in the other one. They were like, apparently the actor was like, I don't want to have this macaque on with me. Like, yeah, that's why the movie flopped. Okay, well, and they hired him. He was. Anyway, I'm just looking at some of these wonderful description, like pictures inside the dolmen. I mean, look at them. They're just crazy, the amount of work they went into these. Anyway, just blows my mind every time. Beautiful work, beautiful work. I mean, when you see how much effort and how much we went to protect ourselves, you can begin to understand how much turmoil the Earth was in, and how much it must have affected these people. I mean, I often wonder what it would be like to live in a world where gods are real, you know, like as opposed to, you know, things we.
The result of which is religion, Neil, and we know that these events in the skies caused people to get religious real quick.
No, it's not religion if it's real. Religion requires belief. I wouldn't have to believe this. I'd have to see it. There's no belief required.
No, religion. I don't believe religion requires belief. If you can see the God in the sky, all the more affirmation. Wow.
Well, what I'm trying to say is that I can see Saturn in the sky right now with a telescope. Actually, with my own friggin' eye.
No, I meant in the polar configuration as it stood motionless in the sky, and they venerated it. And
I'm simply saying that literally the religions are, you know, we took the sun god and whatever, and the moon or whatever we did, but that the idea that this was, I mean, it's just, it simply was. It wasn't a matter of believing. That's all I meant. I mean, you could deny it if you want, but it can still kill you. So, you know, it's like denying a bear. You know, like it's not a wise idea. And I could understand why they thought that sometimes these things talk to you. I mean, it makes perfect sense. I mean, your brain would be broken. You would have to try to figure out a rationale for your actions, and you weren't able to predict the future. So it must have been
your brain
crazy.
was just electrocuted, right? So
your brain was just electrocuted. Yeah, I guess in a sense.
What I'm curious is that you want to know what this thing that they saw in the sky. What are the difficulties of calculating the size of a body that would be capable of doing the thing they did to Mars, that scar face?
Actually, I would say, just by what I see there, is that Mars didn't break into pieces when the electrons were asked to leave it. So that's something. But I would say that my interpretation of what hit that would be Jupiter. I think it was probably when Hephaestus had his face scarred. And then that's how that ended for him.
Does that mean that everything else is eliminated because it has to be that big?
No. It's just that's part of the mythology where Hephaestus was struck by a thunderbolt from Zeus or something, and Zeus being Jupiter.
But I'm asking for a physical, calculation of how close and how big this is necessary to make that happen.
Well, I can make some estimations for you, but I'd have to do some math. But it wouldn't be impossible, considering you know how deep the scar is, and we have really good map terrain, and we know a lot of it rained down back on the planet, And we know that probably Phobos and Deimos are results of that, and probably a few other moonlets and pieces of moon as well, and probably the faint ring of Jupiter, if that's the case. And then you could do the calculation how many coulombs had to be used to move that. So yeah, it could be calculated, but I wouldn't want to have to do it right off the top of my head.
No, I mean, I would like to know like the minimum and the maximum. You know, something too big and something too small. That kind of thing. A range. I want a range so I can eliminate things.
Oh, okay. I see what you're saying. Well, like I said, can't do it today, but at least I hear what you're talking about.
Well, sorry, I was just having a discussion with Scott Ferguson about the space shuttle. You have mentioned it a couple of times that it had spent some time out in a part of area of space where it had lost some of its positive charge that matched the Earth's because it left the Earth.
Mm-hmm.
And on its reentry, the so-called friction was actually an electric charge problem. That because there was a hole there, the tile that had made the hole there, the friction was able to, or the electrical was able to enter into there and cause major problems. And it looks like friction to us, but it's really an electrical process going on, exchange of electrons.
This is a picture on the screen right now. Are different pictures of the same strike. Of the Space Shuttle Columbia was struck by lightning as it came in, and the strike a time delayed shot. So basically, the time lapse was basically the shutter was held open. So this lightning occurred at this point, and this is the debris field afterward. So in my opinion, what happened is that as this went further and further, like an electric probe towards a charged body, the charged body being the Earth, there was a tail of debris of metal chunks and everything leading up into space. And as it came further and further into this point, the charge at this point said, "Oh look, a conduit," because this right there might as well be the same voltage as space. So it went down here, through that, and all the way back up that tail of debris till it grounded out in space. But unfortunately, the wing of the space shuttle did not have the ability to resist the several thousand amps that just went through it, and it got blown off. Likely most of everything that it touched, including the engines. So, yeah, it's a bad day.
So there you go.
That's my thoughts on that.
That's an interesting. Yeah, that's very interesting. Now it reminds me though that you could actually do the same thing with the micro flare. You could determine the range of what it would take to flip the Earth electrically, and whether or not a micro flare or even a nova flare from another planet could around another star could possibly send a wave towards the Earth and flip it, or not.
Neil, I saw a picture there of, I think it was showing elves and sprites and clouds and lightning and the different layers of the Earth. Was one of those showing where the space shuttle blew up? Because it looked like it was entering a double layer of the atmosphere when the charge hit it.
Well, there's lots of layers in the atmosphere as you go through it, because each one of them has different electrical properties, obviously.
No, back on the Google search page, I saw what I thought was a point where the shuttle was superimposed on that picture that we all know with elves and sprites, and
I'm actually
wasn't that the case?
No,
no, okay.
Unfortunately not. Oh, no, you did. You're right. I'm looking at it right here.
There you go. I saw it right there. Space shuttle struck by the.
That was Thunderbolts.info. That's why.
Top. No, top left.
No, I've
Second one in.
already looked at it. I've already got it. It's just you're not seeing it. But yeah, it's Thunderbolts.info. Here, let me give that to you right there. But yes, the picture.
Yeah, that.
Yeah, the picture was basically showing where it was basically at 50 some odd miles up where it got struck.
It looks like it's at a double layer.
It is right around the
right
to the blue elf layer or whatever.
Yeah, it looks like it just had penetrated from one layer to another layer, and then a charge from the top, a layer above, came down and hammered it.
But you can see how much energy, if you could manage to get all the way to 7 miles or 7 kilometers, how dense the charge you're entering into is. I mean, apparently these shuttles normally are so well insulated that they don't allow this type of thing to occur, because that's the real big problem. Is not just the friction of it entering the atmosphere at Mach 25 and then doing a giant bunch of S-turns as you go through the atmosphere, but you also have to sort of bleed off all that charge, which, as we talked about before, it's the same with fighter jets. The canopy becomes highly electrostatically charged, that type of stuff.
Makes sense.
Well, with all the electrons ripping across it, yeah, I bet. Especially when you're in a rarefied atmosphere. Has a rocket ever been struck by lightning? Yes, rockets have been struck by lightning.
Columbia was a result of charge, not friction.
Likely. I don't want to be. I mean, they're going to argue all the time, so definitely.
That's pretty good visual proof, if you ask me. I mean, how much more do I need? Not much.
Well, the question then becomes, well, what happened on the day of the Challenger explosion? And that's a whole different ballgame.
Well, apparently the O-ring failed and blew the fire resulting blew a hole in the side of the tank that was holding all that hydrogen, and kaboom.
No,
I don't think it was
with that, but
much to do with charge.
Well, except that the O-ring's an insulator separating two bodies, one being the space shuttle and the other one being the tank.
No, it was an O-ring that was holding two sections of the outer rocket, one of the outer support rockets that failed, and then
I honestly do not know.
Failed,
I would just interested if we talked about that.
I'm big on this stuff. I watched exactly what happened and all of the like for weeks after it had happened. I watched what the science told them, and we could see it. With the camera, you could see that the fire started down near the exhaust.
I'm not arguing
where the O-ring failed, and then it burned in. Then it burned into the main tank, and it went kablooey.
The question became, what started the failure? That's all I'm at. And we recently learned
the O-ring failed because of the cold.
I'm well aware of what the documentation says. I wasn't trying to argue with you. I'm simply telling you that one of the things that we learned from going over this was the fact that the thrust or the stuff that comes out of the rocket, the debris or whatever, is highly metallic. I did not know that, which could be very dangerous in that regard.
Well, what's highly metallic?
The solid propellant from the thrust rockets.
They're solid oxygen, aren't they?
No. But they are. But they do have. But they basically would be like if you have metallic pieces in gas, it's just like a current, right? So this is the type of stuff that I'm concerned about. Yeah. And you're flying into. I just keep on thinking about because there's been issues like this before. It's certainly not the first time that they thought about this, but now when we're looking at this, we should be so much more careful throwing metal objects through space.
Yeah, but that's Columbia, not Challenger.
I know.
Oh, okay.
I'm simply stating that it's not. Look, the Russian rockets get hit with them too. And the only way you could do that is you have a current. So there must be charge flowing. So, like I said, it's very interesting. I don't know if it's I'm not trying to say, hey, please. But the first one with the one that we looked at from space, that's very convincing. But still, I like to think about these through new eyes and try to understand them.
Yeah, this purple lightning-looking bolt, coming down and intersecting with the path of the shuttle.
Yeah, it's a pretty good sign. Damning. Yeah, that's pretty damning.
You're convicted.
And they try to hide that, which is even more damning. So, you know what I mean?
Well, yeah.
Are you saying that it's SpaceX's stainless steel outer coating is not a very good idea?
No, not very good at all. No, not good at all. That's not how I would put it. No. It seems like it's fun.
Unless they can generate a repelling charge on the surface of that re-entering object that can deflect that kind of energy that's coming down from the double layer, I don't think it has much of a chance. And they might get away with it a few times, but it'll blow up eventually.